So what we're going to go ahead and do is we're going to switch over to the malware box, and then we're going to go ahead and run the exact same command. And then up here, this is my actual local system. We're going to run the API call, pull down one of those reverse shells, that big jumble code that you just seen, and then just pipe it right into IDX, get it to run.
I have spoken to customers who have implemented similar solutions, and I know what a pain it can be. I mean, I spoke to one organization who have spent, and this is not an exaggeration, 4 years on a project.
I just thought about something while you were talking. Have you guys ever even dabbled with the concept of using, maybe this is dumb and crazy, but have you dabbled with the thought of using this as an anti-cheat for video games?
Everyone, it's David Bommel back with the amazing Jakoby. Jakoby, great to have you back on the show.
I appreciate you, brother.
Hey, dude, the thing that you showed us last time was insane. You got to tell us what it was. I was blown away by it. We had so many amazing comments on YouTube about what you created.
Yeah, it's probably one of my favorite projects I've ever been a part of. It's a polymorphic reverse shell generator technically, even though I said last time it was just a generator. But a reverse shell is something that a hacker can run on a target system to gain control of it. Now, most of the shells that are out there, you can go and find them. They get detected really easily. So a lot of time it comes down to having to make these modifications to it to get it to go through. It's a very slow, tedious process. I just managed to optimize it and streamline it and made a program that'll do it for me and on the spot. And then I turned it into an API so I can just do a single call up to it. And every single time I do, it'll generate a polymorphic reverse shell that has never been run before. So it won't match any known signatures or anything.
So you were saying that no antivirus was able to pick it up. Is that right?
So you always want to be careful on the internet saying things like always and never. But at the same time, it's always worked and it had never been caught up until recently. So I developed a polymorphic reverse shell and then got a couple different friends that had different setups with a bunch of different antiviruses. And I just had people reach out to me that had an environment that they could run it on. And so I ran it against Crowdstrike, Elastic, SentinelOne, obviously Defender, a handful of other smaller ones. And it went through every single time.
And in that interview, you did mention there was one company, right, that picked it up and blocked it. Is that correct?
Yeah, absolutely. So at the time, they hadn't picked it up and blocked it yet, but it's someone that I'd been in communication with, and they had a really cool concept. And it's especially awesome because I had been getting frustrated. I know that's weird to say, but I'd actually been getting frustrated that I kept beating everyone because it shouldn't be like that. And so I had been in contact with a company called ThreatLocker. I had met a guy there named Ivan, who was a wonderful individual, helped me out with a few things. And we got to chatting and he started showing me off some of what they were doing. And so they do a lot of behavior-based detection and really, really stick to the zero trust model, as opposed to a lot of these other EDRs that will let something run or scan it and then run something against the output and then block it after. But when it comes to something like a reverse shell, I only need one single command. And if I get to run it, you're already too late. I own the computer. So ThreatLocker does behavior-based detection, and they have a concept called ringfencing that they use, which is a way to track how different applications communicate with each other or different processes. And if I remember correctly, I believe it stays on your system for about 30 to 60 days and studies the behavior of the user to create a baseline for whatever company, individual it is. And then they use that to found outliers in behaviors that aren't normal, and they go ahead and block them in advance before, they allow some sort of infection to take place.
Last time we spoke, you had a sad story, and I think it's important that we highlight this again. You are an ethical hacker. You're not a black hat. And companies should be glad that someone like you is really testing their systems. And like you just said now, you were kind of disappointed that this wasn't getting picked up because, we want to protect companies. We want to help them better protect themselves. It was fantastic that ThreatLocker picked this up. So, at least someone was picking it up. I have to say this video is sponsored by ThreatLocker, and I've asked ThreatLocker to come on and answer some questions and see who wins. Will red team win today or will blue team win today?
Red team versus blue team.
But before we get there, I mean, do you want to say anything else, or do you want to demonstrate, this hack and perhaps how it got blocked?
I'm Jakoby versus machine without ThreatLocker.
I'll go ahead and give you a demo on my main system. This will be the system that does not have ThreatLocker without any sort of detection. So you can just see how quickly and easily that this can be run. And there are, of course, a lot of different ways to implement it. We're going to stick to basics for here just to get the concept across. But I literally just have an API endpoint where I can pass up an IP and a port to, and then a key, which obviously will be changing this after the video for sure.
Yeah.
But this is a simple one-liner that is going to call up to my API, and then it spits out a reverse shell that is heavily obfuscated. And this took a decent amount of work because it's not as easy as just simply obfuscating it, because there's a lot of different detection methods for this that different EDRs and EAVs use to try to find it. Whether it be looking for certain keywords, like you can't have reverse shell inside of one of these, like the word reverse shell, it'll get knocked. That's an obvious one. But there are a lot of other little things that they look for or they don't look for. And even one thing I found out is if you obfuscate it too much, it gets detected even by Defender, which is like at the low end. It is too unhuman readable, and it will, even Defender will block it. Although it be in like CrowdStrike, Elastic, Sentinel, and whatever. So you'll see inside of here, a lot of the times I'll use something like 4 files as the human readable characters. But essentially, just a little things like that, leaving just a little bit of human readable code will get it past certain things. So this was a significant amount of trial and error towards the beginning. So what we're going to do is we'll go ahead and turn on our Netcat listener on our intermediary box.
So that box at the bottom, right? Sorry to interrupt. That's somewhere in the cloud, perhaps, and then the device at the top is the device that's getting hacked. Is that correct?
Yes, absolutely. So what a lot of hackers we do is we'll have a jump box in between ourselves and the target, just as an extra little proxy. In this case, I have a jump box that connects to the target system that calls back to a separate box. So I have 2 of them that are hosted. One's the jump box, one's the actual API itself. You want to try to keep as much segregation as possible. But what we're going to do is we're just turning on the listener for our jump box that we'll be using to catch the shell. And then up here, this is my actual local system. We're going to run the API call, hold down one of those reverse shells, that big jumble code that you just seen, and then just pipe it right into IEX, get it to run. Oh, that's awesome. And you'll see down here, we have connection received. Funny little thing I did on my computer, a lot of hackers, the first thing they'll run is the who am I command to see. You can actually reassign that function so it doesn't spit out what it's supposed to, which is what I did. So now every time someone tries to run it, it just says, I am the ghost in the machine. That's not the name of my computer or whatever, my username. A little fun tidbit. But yeah, we can just go ahead and like pop open the calculator real quick. And you'll see this is on my PC. Hackers use calculator just to test to see that stuff works. So yeah, as of right now, I have control of my main system. You can just go ahead and hit clear screen up there, whatever. And then we can control C out of that. And you see the connection has been cut. But as long as that connection is there, I have full control over the PC. And then in my repository, my personal repository, I have a lot of different persistence methods. Really, all of that API call has to be run every single time the computer's turned on, whether you want to put it into a startup folder, sneak it into their PowerShell profile, some DLL side loading, whatever it is, it doesn't really matter. As long as you can get that single one-liner to run every time the computer starts, again, it'll generate a brand new polymorphic reverse shell. So it'll be different than the shell that was ran last time. And every single signature is unique. None of them will ever be the same as any other shell that's run. I've been working on this for like 2.5 years, slightly on and off, but making little fixes here, taking suggestions from the community, running it past some friends. So what we're going to go ahead and do is we're going to switch over to the malware box.
I'm Jakoby versus ThreatLocker.
And then we're going to go ahead and run the exact same command and pipe it into IEX. And you'll see unable to connect to the remote server. This shows a simple block. There are other ways to also get this shell onto a system. So I want to show that they're not actually just blocking the API, because anybody can just simply block an API if you know what the website is. And that's really simple. I don't want to say there's nothing special about that, but once this website gets out, like, it's obviously going to be blacklisted everywhere. So that isn't much of a mitigation in itself. So I have a bunch of other methods that I can also use. So for example, what we're going to do...
Just before you do that, sorry, Jakoby, to interrupt again, because I'm slow, right? I'm the boomer, so I'm slow. That box, the red, like the second one that you just run the command on, how is that different to what you just showed us? Is this running ThreatLocker?
Yes. So absolutely. So now, the red box that you see right here is my junk malware laptop that I've put some heat onto, and I went ahead and I cleared it out, wiped it completely, and then connected with the ThreatLocker team. And the implementation to get ThreatLocker onto the system was so much simpler than I thought it was going to be. I actually haven't even brought that up to you guys. It was actually impressive. It was actually impressive how quickly and easily it was to implement.
Impressive. Very nice.
Like, shockingly, it almost feels like they shelled me. I'm not even going to lie. So the setup was absolutely brilliant. So yeah, this is just an extra laptop. We got ThreatLocker running onto it right now. And so again, I want to show that they're not just doing something simple as like a DNS block, right? I have a bunch of other techniques, and some of them I'm actually not going to share today because they're that secret, but I'll pop a couple of them out.
That'd be great, because the last time you did that DNS bouncing thing, man, that was crazy.
Yeah, the data bouncing was absolutely brilliant. I'll have to talk to these guys at some point. I haven't got to test through that with them, but I'm curious to know how that would work as well, actually, because that is the single best data exfiltration method that has ever existed, or probably ever will, until somebody invents teleportation to where you steal it on a USB and teleport that USB drive. That would be data bouncing. If you guys want to Google that, it is the coolest data exfiltration method in existence, period, hands down. Without a doubt.
Just for everyone watching, I've put a link to our previous video where Jakoby goes through this in a lot of detail. I mean, it's really insane what he did. So I highly recommend that you go and look at that. I often get comments on YouTube like, David, this stuff isn't real world. This stuff is too simple. So if you want to really see like hardcore, crazy hacking, go and look at that video. And it's really impressive, I think, Jakoby, that, ThreatLocker is blocking this, because if they can block, you, that means a lot of companies are going to be a lot safer.
It's honestly impressive.
Impressive. Very nice.
And so again, I want to highlight that they're not just doing some basic DNS block my website API. So there's a bunch of different methods for this. So again, what we're going to do is I'm going to switch back to my main system again, just to show you something. So we'll go ahead and run this one more time just to show it generated. So obviously, every single time I run this, it generates a brand new one that has never been run before. So using the API is how you get a fresh new one every single time on the spot. But if the API itself is blocked, and again, you could make proxies to send this to another one, so it's a different website that pulls it. And that might be something I look into the future. But you can also just simply copy and paste this reverse shell and put it somewhere, pull it down. Like a lot of my Ducky script payloads that I got, known for, is me just hosting a payload on GitHub and using something like invoke REST method, invoke web request to pull it down and execute it. So you can still do that as well. One of the sneakiest techniques that I've ever seen, and it honestly changed the trajectory of how I write some of my malware. There's a guy on Twitter, his name is Alzared, and I want to say almost a year and a half, 2 years ago, he just randomly decided to share with the world that you can use DNS text records to store different strings in, or in this case, malware samples that you can pull down. And what's really cool about that is a lot of systems, they like to look at using things like invoke web request and invoke REST method. And if that's going someplace that's not good, then they'll block it. Or a lot of those sometimes are even, I don't want to say blocked by default, but they're nerfed to the ground. So he pointed out that instead of using either one of those, you can actually use resolve DNS name to go to a text DNS record. We'll pull the type down, it's text. And then so this is pretty cool. I'll actually do it without doing that. So if you run it just like this, you'll see the malware sample right here. So it'll, this is the DNS text record itself, shows it's a text, blah, blah, blah. And then the strings. Yep. What it does, DNS text records are typically supposed to be, I want to say the limit was 255 characters, but there's a different way that you can pull them down where it'll just split your string into 255 characters for you. And then if you saw the full command that I was just running there at the end, we're going to pipe it for each strings and join them. And here it is, the reverse shell again. Instead of, now this one is not dynamic. It's not technically polymorphic. Like it is the output of the polymorphic reverse shell in itself. The call itself is not polymorphic. Every time I run resolve DNS name, it's going to pull down this exact one. So that is a slight weakness, if you want to call it that. So this might not be the persistent method that you use per se, but we're going to go back over to our malware box now.
Just want to, another question, because I'm sure the audience will want to know this. Though you said this is a laptop, right? So this is a physical box.
Yes, absolutely. Yeah, I have them both in front of me right now. I'm just using a capture card to pull the screen over.
So you've got two physical boxes. One is, this is the one that's running ThreatLocker. The other one is running just like Windows Defender or something, and you're just getting past that all the time. But here you perhaps struggling.
Correct. To be fair, I have another antivirus on that one. It's just disabled for this video.
Okay.
But even if it was on, it would walk right through it. But there's some other things that it kind of sometimes messes up, some of these other methods that I just wanted to be cleared. So we did pull that down for here. So we're going to go down to resolve DNS name again. So I noticed that when we do the resolve DNS name, I can actually pull it down. So you see that we're on the ThreatLocker box. I am able to pull the string down, but if we go to run it, however, with that piping it into IEX invoke expression, it will spit out all these errors that you see here. And
IEX, you put, that's PowerShell, right?
Correct. Yeah. So if you see right here at the top, exception colon with 2 arguments, no connection be made. I got a more verbose error message the first time when I was running it off stream, but essentially it said ThreatLocker had refused to allow it to connect because it was not an authorized attempt to access one of the sockets that I was using to block it out. So it's looking like it's actually feeding that error through really quick. It clears the screen and then shows that the connection is not allowed to be made. They're blocking my connection to the site. But again, keeping in mind that since we're not doing an API call right now, this isn't actually going to my API at all. This is going straight to the jump box where they're refusing the connection from inside, which they're literally the first people to do that. It feels good and bad.
It feels bad that you didn't, you couldn't pop it and take control, right? But I think for all of the defenders, it's the best news ever.
Yeah. So it's that. Yeah, there's a lot of emotions in that one. It's good that, well, not good that I finally got defeated, but it's also awesome that these guys took the time to take it seriously. Because I don't know if you for some of the people that have been following me, if you saw some of the bounties that I turned in last year,
exactly.
I got royally screwed over.
Yep.
And a lot of the vulnerabilities are still there. Some of them they haven't deemed high enough. And then a couple of times they've gone through and, made a couple of changes behind my back. But the thing is, the problem with the changes that they made, since they didn't consult me, it took me all of about 6 minutes to just slightly change up what I was doing and, just fix what they did. Like one of the times, like I'll say for hypothetical, easier to illustrate purposes, in order for them to beat my reverse shell, what they were doing is they were adding an invisible Punjabi character at the end of my string. So one of the other methods you can use instead of pulling from DNS text records, you can pull it from the description of PowerShell modules, because PowerShell modules are accessible to all things. So what you can do, let me switch back to this one. We'll do a clear CLS. We'll do find module FEMO for short. We'll do C2. There shouldn't be a module called C2, by the way, but here we are. We'll grab the description and it should just say this is an example, something along those lines. Oh yeah, except it's in base 64 because malware.
You can read that in your head, man. You're living in the
Yeah.
matrix, unlike us normal people.
There's a couple of them that I have absolutely memorized. Start calc. This is a side. I think I'm gonna get that tattooed on me. Start calc in base 64, just because that's always my test base 64 string. That's completely random. But so you can put malware in the description of PowerShell modules. PowerShell modules, you're not necessarily supposed to be able to access the code that's inside of them without doing import module, going through the UAC, and then there's other processes that will, corporate policies that might stop certain things. Absolutely nothing stops you from querying the description of a PowerShell module. And you can fit a lot in there, or you can combine them. So I put a reverse shell in the description of the module. But I noticed one of the fixes they tried to do, and they tried to nerf me from doing this again, is they put an invisible Punjabi character at the end of the string of all the descriptions of every PowerShell module. So if you pull it down and try to run it, it'll error out. But that's a simple regex expression to get rid of any characters that aren't, AC. So I added an extra like 13 characters to my one-liner, kept it under 259 characters, so it still fits in this run box down here, which also just random. They nerfed me here too. If you guys know all of my Ducky script payloads, everything, like I said, it's all about hosting a payload up here, using invoke rest method to pull it down and then execute it, which I did from the run box with like the rubber ducky, because you just window R, type it in, and it opens up, runs it without the window popping open. What they did is they made the run box work with PowerShell version 2 now instead, which doesn't have access to invoke rest method or invoke web request. So when I run this, it's going to say, sorry, it's been depreciated. We're running PowerShell 0.2028. So they actually nerfed all my payloads. But the little mitigation processes that companies like this try without actually consulting someone like me, like it's a joke. It's a joke. So for someone like ThreatLocker, like for them to finally reach out, for us to have the communication to go back and forth, and then for me to finally get on to one of their systems where I could test with their software and get beat, it was so bittersweet, but it was still sweet.
ThreatLocker wins.
The thing is, you've made the world a safer place, dude. There's huge, kudos for doing that.
Can we go back to, you had mentioned that the first time you had run the commands on your machine, that there was a more detailed error message. If you go into the agent in the system tray on that machine, you should be able to reset the history. And then if you try it again, hopefully the first error will pop up again.
I can just go ahead and reset history, you're saying right here?
Yeah, that's the one. I'm curious to hear how you would go about implementing a procedure to block the DNS bouncing of data. I
am not even going to lie to you. I don't think it's possible because it was one thing when it was data bouncing, but then I found out that I could use the Google DNS lookup servers. Like you can go to like dns.google.com and you can use it to query DNS records, right? So I'm actually using Google to do it for me. So I really just don't know how people are going to, how they would block that. I'm not even going to lie. That's why I was so curious to see like how, what kind of implementation you guys might be able to try to pull off this.
We can do some testing with
maybe
it.
We shared some information.
But we might, with ring-fencing, like we can block PowerShell from the internet.
I was going to say, I have a suspicion I might know what's happening when you try and do that the first time, Jakoby, which is obviously with ring-fencing, we're controlling what PowerShell can do, where it can go, where it can connect to on the internet. From my experience playing with it, specifically with reverse shells, the initial connection outwards from PowerShell to your reverse shell server, the actual connection itself is actually permitted. As soon as so much as a byte of data it tries to transmit, it's then blocked. So I think that little sort of glitch that you saw where it looked like it was connected, but then it didn't, it was because soon as data was transferred back through. Correct. I saw that before myself with a piece of malware, PowerShell malware that we came across, and it basically, it looked to me, for all the world, it's like I'd get the connection on the Netcat listener and I'm going, oh my God, this thing is after bypassing ring fencing. But when I actually tried to do anything, i.e. press return or do anything that involved data going back and forth, the connection was immediately closed. So I suspect that might explain what you're saying.
Yeah, that's actually exactly what happened. I got connection and then I always do start calc That's just the thing.
And once you type anything, it disconnects you.
Connection was immediately dropped. Immediately dropped.
That would explain it.
I was actually caught off guard. I was like, yep, I got him.
You thought you'd bypass ThreatLocker.
Yep. So yeah, I messaged him immediately. I was like, well played.
Just to confirm, we didn't need to do anything. We didn't need to configure anything, set anything up, tweak anything, adjust anything, block anything when we saw it happening. It's just purely because we control where PowerShell can go on the internet. Basically, as you said earlier on, we block by default. So it's not as if we had to adjust for your behavior. We had to block a particular location. None of that. It's just we say PowerShell should not be allowed to access the entire internet. So we don't allow it to access the entire internet.
Except what is whitelisted eventually.
Correct.
As.
Exactly. So
correct, yeah.
Deny by default, permit by exception.
Which again is absolutely brilliant. People really underestimate the strength of PowerShell. They think that because it's not as robust of a language and quote unquote, you can't do as much, that it's somehow inferior to the other programming languages that people use for malware. But there's two very important things. One, I'm going to let you in on a secret. I know it's going to be in the video, but if you guys tell anyone, I'm going to be so mad. No, I'm just kidding. I use some Python on my malware server where the API is done. Not for this particular project, but I have other things that I'm working on where I do use some other languages. And the thing is, it doesn't matter because it's all done server side over there. And I'm just using PowerShell to collect whatever I need afterwards. So I can still use other languages elsewhere. The thing is if you're doing malware development, in my opinion, you should always be using PowerShell. It's a LolBin. For you guys that don't know what that is, that's just a living off the land binary, meaning that you don't have to download any third party anything to make it work. You don't have to convert this to an exe and then try to get the exe pass because you made it look like a picture, even though that's fun. But you just don't have to. It's extra. So PowerShell, the way that I try to explain it to people, even the difference between PowerShell and the local system and C# is C# so heavily looked after and monitored in all the processes, whereas it's seen as an attacker, whereas PowerShell itself is more so seen as the bodyguard or the bouncer that's outside of a club that's hey, you can get in, you can't get in. And it's usually as simple as that, a binary yes or no. You can get in, you cannot. And all I need is the yes. Everything else is done server side, and I can do a simple API call with PowerShell and do whatever I want. So that's something that nobody else really, I'm not even going to lie, nobody else really takes seriously. They're it's just PowerShell. It's it's all that I need.
Could I wager that most attackers take it pretty seriously?
Exactly. Yeah.
Even if
absolutely.
defenders don't. I mean, I saw statistics that something like 90% of ransomware attacks will use PowerShell at some point in their execution. Might be running remote code, it might be downloading payloads, running it. I don't know if you guys are familiar with, so as you may have guessed from my thick Michigan accent, I'm not from around these parts. I'm from Ireland, and the Irish Health Service, the HSE, was wiped out back in 2021 by a ransomware attack. But they did a fairly detailed analysis of what had happened. And it all started with a malformed Excel document, basically, that opened PowerShell. PowerShell deployed a Crowdstrike beacon, basically doing what you're showing for all intents and purposes. But as part of the breakdown, PowerShell was used at about 5 different stages of that attack. So they used it to, as I said, deploy the Crowdstrike beacon. They used it to delete shadow copies. They used it to download and execute the payload. So 5 different stages of that complex attack involved PowerShell. And as you said, Jakoby, it makes perfect sense to use it because it's on every Windows computer and you can do so much with it. It's one of the things that we try and tell people about all the time is one of our taglines, by the way, is stop PowerShell from eating your lunch.
Why you trying to eat my food? You can go get your own food.
Because
that's brilliant.
Yeah, it's so easy to weaponize.
As I've been trying to get more involved with different communities, a lot of the friends that I've been making recently, they're not even hackers. The PowerShell community is strong, and there are a lot of people that do some amazing things. And, I've done a couple of demos with them and just showed off what I'm doing with PowerShell. And it was so crazy to be in a room with multiple Microsoft MVPs and demo something. And then at the end of it, I watched jaws drop, the questions I was getting asked, the things people were saying, oh my God, I didn't know you could do that. I never really thought about, this has always just been like for administrators to rename files or batch, this or that. And, they just, even some of the best, that was when it really, really hit me that I was like, yo, you're onto something here. With all these Microsoft MVPs where they don't necessarily in security, but they find bugs all the time and they report them. They just don't actually know the full scope of what they just reported. You know what I mean? So a lot of these guys, I'll study some of the work that they do, the bugs that they turn in, or the little techniques that they have. And it's like, do you have any idea what you've just done? I know that like you're such a good person that you can't even imagine how that can be used wrong, but you just made a whole C2 platform and you think it's for controlling OBS, but guess what? Now every single streamer out there is now vulnerable because you streamlined the entire process of controlling OBS, getting their keys, everything. You streamline the whole process and control it with PowerShell. I turned it into a little module. I literally have a PowerShell module to make other PowerShell modules malicious, like submodules for them, just to add slightly more functionality to them so I can use them in a way you absolutely never intended. And it's crazy what's out there. But seeing like, again, all those Microsoft MVPs they're geniuses. They are so much smarter than me. Like, it's crazy for me to sit in front of some of these guys and I'm like, oh my God, I'm a fraud. Oh my God. They're so smart.
You're amazing, dude. That's why I wanted to have you back on the channel, right? Because if a company can block you, then it shows that they're doing something right.
If we go back to here, I've gone like an extra mile. And so I haven't had to do any of this stuff. So again, based off all the testing I've done before with all of these different antiviruses, if you look up here, it shows API 1. I'm on version 4. This is the public one. You know what I mean? But what we're going to do is after key right here, we're going to do and E for encoding equals, I can do B, we'll get it in base 64. And then it's stackable. So whereas I could do just this one we'll do 0. So you'll see it. You can do it in binary, get the output in binary. But again, these are stackable. So I can do like base 64, then reverse it, put it in binary. So again, it'll be here. Then we'll do a shift, right? So then we'll shift every single character up 2. So it'll be 2s and 3s, right? I just have this for now. It's X for
Nice.
AES encryption as well. Now the AES encryption itself is hard coded. Typically you'll want to be able to pass your key in right here or whatever, you know what I mean? But for my testing purposes on V1, now it's AES encrypted. And then we can go even a step further. And this is where there's going to be a lot more experimentation. And hopefully I can continue to work with ThreatLocker because listen, when you guys slapped me down this morning, listen, I'm not going to lie. I'm happy for you, but I'm coming for you. Like, I'm coming for you. And so we'll do L at the end here. And this one's going to take like 4 or 5 seconds because it's going to do all that and then spit it out in shell code. Now, once it's in shell code, we can now do DLL side loading, process injection. I mean, there's an insane amount of other options. Again, I'm not sure if this will make it into the video per se, but we're going to import this module LolBins, do show modules. This is a module that I made that is working based off of the website, the LolBins project. Those guys, they're my heroes. They're so smart. So I go on there, let me pull open. Yes. Okay. So we're going to grab all 3 of these, we'll copy, we'll paste this over, and then we'll do existing LolBin paths, actual XC, cause I'm lazy. Yes. I made an alias for clear screen. So it's just C. And then we'll go to the existing LolBin paths. And these are all the different LolBins that were found on this system. So every single one of these can probably be exploited in some way or another. You know, obviously you just saw like Mishta. Mishta gets, detected a lot. But there are a lot of them in here that I can use for different implementation methods for getting the reverse shell string onto the system, or having to go through shell code or whatever else. So ideally, there might be some more advanced demos later, highlighting some of these.
So just to explain, Jakoby, you mentioned at the beginning about sort of behavioral based detection. That's part of what we do, but it's not all of what we do. The main
Correct.
thrust of our product is around control. So it's basically a set of rules. Now, there's a few different aspects to it. You've obviously pointed out ring-fencing, which is fundamentally a control. It's about allowing applications do what they need to do and no more. We also have an allow listing component. So allow listing, again, is a control. It's what can run and what can't run. Obviously, it's going to stop not just bad things like malware or ransomware from running, but also good things that can be misused. So your WinRARs and 7-zips and remote access tools, AnyDesks, things like that, things that are not necessarily bad, but that can be weaponized and misused. But again, we've got other control components as well around networking. We've got controls around storage, data, what programs can access what data. But most of what's been blocking you, most of what's been frustrating you is not because we've detected you're doing bad stuff. Most of what's been blocking and frustrating you is because we fundamentally deny by default. So, as I said, what can run and what can't run, but also behaviors. So I don't want to say there's no detection required. We do have a detection component as well, which is ThreatLocker Detect. There's one of the Detect team on the call with us here. We are seeing that you're trying to do these things, but again, we're seeing you're trying to do these things whilst they're being blocked. As you correctly pointed out, there's very little point in detecting after something has happened because it's probably going to be too late. So what we're doing is blocking first and basically detecting second.
Which is exceptionally cool. Absolutely. Which is exceptionally cool for two more reasons. So one, of course, you're doing like advanced mitigation, but you're also following like something that was pounded into us into the military is the anagram PACE. Like you are not prepared unless you follow PACE. You need a primary plan, an alternate plan, a contingency plan, and an emergency plan. So while there is detection, it's not necessarily the main thing that's being used, but it is the alternative plan. And then there's a contingency plan and then an emergency plan. But again, the coolest thing, and this actually works out well, PACE, P, you guys are being preemptive. That is the big difference, right? A lot of other people, they do follow PACE actually, and good for them. It's just that P doesn't stand for preemptive for them. It's just primary. So that's pretty cool. But what you were saying about blocking a bunch of other systems like AnyDesk and any other softwares that could be used, again, something you guys should for sure look into is the LolBins project, because that's literally what all of these are. So while you guys do block things like maybe PowerShell for such, Pester, for example, has a way of using PowerShell from inside of Pester, and in the processes, it will show it as being Pester unless you go through like 3 deep in like Procmon or something. You'd have to like go 3 instances deep before you even see that it's calling PowerShell. Now, I lied about Pester because that was actually only 2 deep. Let's be okay. I should have, clarification. But there are some of these other ones that do also call PowerShell, but the process is so deep, like it's like 3 or 4, because it's like their first call, and then they call into Pester, and then Pester calls a process that then calls PowerShell. So sometimes when it's nested, a little bit further, those processes don't get caught. Now, I don't want to speak for you guys, right? You know what I'm saying? But you guys are the only ones so far that I've heard that have something implemented that's looking for this level of integration like that deep. So that's pretty cool.
I'd love to see that on a machine running ThreatLocker, and it's certainly something we'd love to explore with you. Just on the subject of LolBins, by the way, so obviously it's something we're very much aware of, and preventing weaponization of trusted software is almost as important as what can run or what can't run. So we've got a bunch of default ring fencing policies. I think about 23 or 24 default ring fencing policies that every new group of machines will get. So it's everything from PowerShell to curl to regserve to run DLL. Basically, same principle as with PowerShell, just controlling what they can get, what they can do, where they can go.
4 files. That
4
exact
files is
list
another
that
one.
you just started naming off, that one's right in there. Yeah, 4 files has been like my go-to for the last couple of years. That's probably the first one that I try. It's like the first one that's like just off of the list of normal ones checked, like how you just listed 4 of them and you technically left all 4 files. You're aware of it, but that's also one that a lot of other people leave off, specifically using 4 files to call in, execute, or whatever else.
So, as I said, we didn't have to respond to anything Jakoby was doing. We didn't have to change anything specifically for him. It is a relatively typical setup that he's working inside. We did add some policies. So we have a standard set of, I think it's about 40 policies in total that, any new group of computers or group of workstations will get. We did add a few extra ones, which are basically Microsoft recommended ones. So basically Microsoft had a list of things that they recommend that you should block to harden your environment. So things like WSL, that kind of stuff. Now I know Jakoby hasn't used any of them in this demonstration, but we did add sort of sprinkle a little bit of those recommended policies on top of the default set. And we did tighten up on networking as well. Again, not specifically relevant to what Jakoby has been doing or using, but we did add some network control policies just in case he did manage to do something that, bypassed our controls, which thankfully he hasn't so far.
I mean, Jakoby, is white flag time for you, right? Or you're gonna come back with a vengeance?
The gauntlet's been thrown down, Like, here's the thing. Like I was showing you guys earlier, when I was doing all the testing with all the different antiviruses, one of the things that made me the most frustrated is how much I worked on this project before I decided to start doing that level of testing. Because by then I had already implemented a bunch of the other different implementation methods, including the extra encodings and the reverse strings, the shifting, the AES encryption, shellcode. I did all of that and I was so excited. And I started getting onto these systems to test them. And I was like, I can't wait to, try out all this stuff that I spent hundreds of hours working on. And then I beat them without ever going past stage 1. And it honestly, that part was frustrating. So the fact that you guys beat stage 1, like, I have been waiting for this. I'm not saying I'm going to make an example out of you.
No, please don't. Come on, can I?
No. It's just you guys are brilliant though. It's great.
Can I share something with you that I think you'll appreciate or enjoy? So if we categorize everything you have done or been doing or trying to do as the genius way to do it, I'm now going to explain the dumbass way to do it as well, which amazingly enough is just as effective. So you obviously know a bunch of PowerShell, a bunch of coding. I don't know either of those things, right? So what I did, and it's one of the part demonstrations that we do, is I went on to revshells.com, picked PowerShell as the method. Yeah, gives me the PowerShell code. So you put that into a machine running Defender and immediately it gets gobbled up. So it's known malware, basically. It says, this is a malicious script, you can't run it. So I went to ChatGPT, pasted the PowerShell command in there, and I said, can you obfuscate this, please? So it obfuscated it a little bit. So I said, can you obfuscate it a little bit more, please? So it obfuscated it a little bit more. We went back and forth for a while. So I tried to run that and it failed. And then I said, then I tried to run it again and Defender picked it up as malware again. I said, your obfuscation isn't good. It's just been picked up as malware. And we went back and forth. And eventually I basically said, look, there's 15 errors on that. Are you even a computer? So at the end, it spat out an obfuscated version of this piece of code that I got from revshells.com. Does not get picked up by Defender, functions absolutely perfectly as a reverse shell. So while what you're doing is brilliant, what I'm doing is the exact opposite, but is equally effective. Well, sorry, maybe
Correct.
Not equally effective, but sometimes kind of as effective.
So check this out. I've already streamlined exactly what you just said. So 2 things.
Yeah.
One, the website that you're talking about is made by Ryan Montgomery, or 0 Day, as he goes by on Twitter. He's a good dude. He's a good dude.
It's an awesome site.
So he made revshells.com. And then I was telling you about the different PowerShell guys and how they create things all the time. And they're like, they don't fully understand what they've done. I made a submodule for a module that Doug Fink, he's one of the PowerShell guys. He's probably hands down top 2 smartest PowerShell guys in existence. He's the one that made the module PSAI, which is so you can get access to, AI through the PowerShell console. So I made a submodule for his PSAI literally just to generate reverse shells to do exactly what you just said. And the only thing is like the training that you have to go through it gets to be a little annoying because the main thing is you have to, it always, ChatGPT likes to make things verbose and try to make things clear and legible. So it likes to use words that make you understand what it's doing. So it likes to randomly name the function reverse shell or something along those lines.
And that'll get picked up.
That's where it's getting busted. So it took a while to even come up with a prompt that could get it close. It's never been proficient or like reliable enough for me to use it like kind of like regularly, I guess. But no, 100%. If someone out there can sit down and engineer the perfect prompt, we'll go ahead and call it the prompt father. If you see this video, I'm talking to you. If one of you guys can engineer a prompt that's good enough to obfuscate it, but not enough so it's not human legible, but also gets blocked by like the small things, while also taking out keywords like rev shell, reverse connection, anything like that. There's a bunch of those. You can find them pretty easily. Which if you guys don't know how bad like Defender is, this is something funny that I did. I posted it as a Twitter status just because I thought it was funny, but I literally made a function called like reverse shell and then ran it in the console and it doesn't work. I just changed the name of the function to not reverse shell and it works. So like that is how like lenient the linguistics are when it comes to the system. They really do have hard coded. It's not even like it's a slightly regex, form fitting anything that's roughly here. No, it was literally like, you can't name it reverse shell, or maybe it might have been rev shell.
That's Windows Defender,
how
right?
often. Yeah, this is just Windows Defender right now.
And so, so what you're saying is Windows Defender can't pick up even the most basic stuff, it seems?
Okay, no, so even that one works, but one of them got detected. I found the exact one. It's some form of reverse shell, but it got detected. I just named it not that, and it goes through. So, but yeah, if anybody wants to take that challenge and see if they can get ChatGPT through the API through Doug Fink's module, yeah, you can get a whole polymorphic reverse shell generator just like that. It just might not be consistent per se.
Yeah. Oh, but there's more as well. Because I made sure to prep it, go all doomsday in case somehow you did manage to get a shell. Because even if you do somehow manage to get it, well, the idea was even if you have a connection, well, we're going to make sure that it's very, very difficult for you to do anything. So if you were to try to say, read a file in like your documents or your desktop, and you can even try it on your machine right now, you shouldn't be able to see what's inside those folders. It was a challenge I gave to a local college cybersecurity team. I gave them a box of downloadable web app and made sure the settings on it were as easy as possible. And then took off things like Defender. I took off like other security measures and only had ThreatLocker on it. They were able to get in, and I don't blame them. When I was going to testing, I couldn't get in. They had a flag on the desktop that all they did to win was read off the contents in that flag text file in the desktop. They couldn't do it. There's no way they were able to read it. And that being said, if they were on the physical machine, you could just open it with Notepad and it would have been fine.
Oh yes, that's blocked as a whole, so I can't programmatically make it.
That being said, if you open up something like Notepad, you could do it in there.
Yeah, that's what we're about to do. But make one this way. Do test. Cookies is my test string for everything. I do get content. There's something blocked by search posture report access. Oh, that's even for that. I don't know. No, there's no way you guys caught that. That was autocomplete that got. Yeah, that was autocomplete.
That makes sense, actually. Yeah,
they got rocked. Yep. So even if I did get the reverse shell onto the system, again, I think you guys, and you can give clarification. I mentioned this earlier. I think you guys said you have this software on the individual corporate system for like 30 to 60 days to study behaviors.
Doesn't take 30 to 60 days. In most environments, it's a week. maybe
A
at
week?
most 10
Oh,
days
okay.
for us
I'm
to
not sure why I had that number in there, but yeah. So
effectively
if
what we
you
do
have
is
a
we
system and someone's not programmatically going around trying to grab text, then there's no reason to allow it. So
and to be
even
honest, there's
then,
some things that we don't even learn anyway. So the likes of storage control policies, that what Nick set up there, we don't learn them. What we learn is application control policies. So basically what needs to run on a user's machine. We create a list of rules fundamentally based off that. And as I said, after a week, 10 days, typically, you're in a fairly good position or fairly close to the point where you should be able to secure. But we do it with customers on call. So it's not as if they have to set everything up themselves and figure out how to use everything. We very much hold their hand all the way through the process.
So, guys, I'm always the slow one in the room. Explain to me how this works. So, like, how are you doing this? Is there software installed on the local computer? I'm assuming that's true. And then how are you stopping like all of these calls? So can you just give us like some understanding of how it actually works?
So fundamentally, yes, there's an agent installed on the machine. Very low impact, very low CPU use, very low memory use, typically, 0 to 1% CPU and a couple of hundred megs of RAM. The reason it can be so low impact is fundamentally it's just making binary decisions. It's making yes or no decisions based on things that try to happen. So as I mentioned earlier, we've got controls, fundamentally is what we do. So we've got application control, so allowing certain things to run and then blocking everything else by default. All the stuff that Jakoby's been frustrated, or a lot of the stuff Jakoby's been frustrated with here has been ring fencing, which is just about controlling what applications can do. That which is on the screen at the moment is storage control. So basically blocking certain applications or blocking all applications from accessing certain storage locations. Is another function, and obviously we've got network control as well, which Nick mentioned a moment ago, which is just controlling outbound and inbound network traffic. Again, all from the agent at the endpoint.
How does it do this though? Because I mean, if it's just a piece of software, does it have access to the kernel, or how's it actually intercepting everything?
So fundamentally, there's a couple of pieces to it. So we've got a service and a driver. The service is the bit that makes the decisions. The driver gives information to the service to make those decisions. So it basically says, this thing is trying to run. The service then says, allow it or deny it. Pretty straightforward, really. That's structurally and fundamentally, that's it. Obviously, we've got a portal where we configure all these policies to allow certain things, to deny others. We've got a learning period, as I mentioned, where we build all those policies out, in most cases automatically. So it's a really, it's a really light lift in comparison with some other similar tools that employ allow listing, where you have to basically figure out everything that's required. You don't need to do that with ThreatLocker. We pretty much figure out what normal behavior is. Yeah, so as long as you stay within those boundaries, fundamentally, we're not even going to get in your way. You're not going to notice we're there. It's not like we're using, AI or black magic or something trying to figure out if stuff is good or bad. We don't really need to do that for the most part. Although, as I said, we do have detection capabilities. They're just not the primary method of protection.
So the difference here is, rather than trying to discover if something's malicious, you're just blocking everything and only permitting certain things that you've already predetermined are good, right?
Correct. Deny by default, permit by exception, fundamentally.
I just thought about something while you were talking. Have you guys ever even dabbled with the concept of using, maybe this is dumb and crazy, but have you dabbled with the thought of using this as an anti-cheat for video games?
We have not.
No, Rob,
sorry. Okay, hang on a second. Maybe the nerds in the room have, but no.
We have.
You have? I was just thinking about that because so they have all these streamers and they're all cheating. There's so many of them that are cheating. It's ridiculous. So I used to do system checks. I would hop on with some of those streamers and do system checks, and I had different PowerShell scripts and such to look for, different programs, whatever it was. Look through the registry because some of the bigger ones, they all make registry entries and it's so predictable. It's easy to find, but nobody would trust me to actively have stuff on their system to stop them from cheating. That's actually kind of big because it's ruining the whole community.
Yeah, actually, we are stuck right now talking about partnering with these tournament organizers that run millions and millions of tournaments to harden their machines so no one can cheat on the tournaments.
Oh my
God! Because you learn the game, everything that the game needs to run, and we block everything else. So if they're trying to run a script, wall hack, input, ESP, nothing will pass. So yes.
I was just really thinking about that. You guys could do some work in the anti-cheat
We're
area.
on it. We're on it.
That was my first week.
My God.
My first week here. That was like my big thought.
Okay. I love you guys so much. Oh my God.
Feelings mutual, Jakoby.
Oh my God. I'm so sorry. I thought about that spur of the moment.
This is why red teams must work together, man. No, dude, it's great. I think someone like you doesn't get enough recognition, and it's great to see, you guys working together on this.
You could save online gaming. Like, it's ruined. Everybody hates it. Like, I'll cut that for there, but we got to talk.
Recently, Crowdstrike had this blue screen wonderful event. Obviously, very sarcastic comment. How is this different, and how is that not going to happen to my environment if I run this?
So, yes, the unfortunate event. There's a few different things, or a few things I suppose we do differently to tools like Crowdstrike, not only Crowdstrike. First and foremost, because we are primarily a proactive, as I said, default deny solution, we don't require constant updates to the program. Basically, it does what it does, irrespective, for the most part, of the threat that's thrown at it. So we don't need to respond to individual threats, to individual known bad behaviors, because we're not depending on detecting those individual threats or known bad behaviors. So the software itself, the agent itself, updates very irregularly, or not regularly, if I could put it that way. We, unlike something like CrowdStrike, which because of the nature of detection, they have to push out updates that fundamentally change their driver, upwards of 10 times a day. We typically wouldn't change our driver 10 times in a year. And obviously, because of that, we can be a lot more careful and slower and more considered in terms of rolling a new version of ThreatLocker out, a new version of the driver out. So again, it's not something that's going to be changing 10 times a day. It's more likely 10 times a year, and is done very carefully and slowly and in stages. The other thing I should mention, by the way, is obviously our driver does, in the grand scheme of things, not very much. It gives information to the service and then it performs actions. It's not doing too much outside of that, because most of our processing is done in the service. The service is not running in the kernel. So the service is not something that would potentially cause a machine. Like, if the service crashes, it recovers. If the driver crashes, it's blue screen town. So because most of the processing is done in the service, it's very unlikely.
No, that's honestly, that's huge, actually, as far as everything's in scope and in ratio. So without having that many interactions, between 10 a day to 10 a year, and then never, of course, pushing on a Friday ever.
Exactly. What about 0 days?
Same principle. Again, because we block everything, we don't need to block individual threats, generally speaking. The same principle applies to lots of stuff. Remote code execution. I've seen, you'll probably remember this one, Jakoby. Remember Print Nightmare? I've seen Print Nightmare being exploited or trying to be exploited on a machine running ThreatLocker. And it's really interesting because you see Print Spooler creates a DLL tries to execute, execution gets blocked by ThreatLocker because default deny. For the most part, and again, look, never say never, and nothing is ever 100% secure and guaranteed 100% secure. But for the most part, we don't need to respond to individual 0 days. For the most part, something is going to try and run, which we will probably block, or something is going to try to happen, like the LolBins that Jakoby mentioned being used, and hopefully we will control them. So
I'm just trying to think of the questions that the audience would have, right? Next question is operating systems. Which operating systems are supported?
So basically Windows, Mac, and Linux. Windows, technically from Windows 7 onwards. And as well as that, and it feels so weird to say this in 2024, we do have an XP agent that has just become available. But look, it's a sad fact that some customers do have, OT machines basically running XP. Similarly, various flavors of Linux, obviously as well. So Linux Agent is just been released, or is only recently been released, but Mac OS as well, obviously. So last 3 versions of Mac OS are supported too.
One of the biggest concerns I think for businesses, I mean, and you guys can tell me, based on your experiences working with many businesses, is if a secretary has a laptop or a computer, right, they only should be running a very limited number of apps. And I suppose that's where you're, blocking everything by default. You're only going to allow that person to run Word and Excel and perhaps a few other applications. Did I understand that right?
Correct. I mean, realistically, 98% of users do the same things with the same software every single day. You know what I mean? They use Office, they use browsers, they use video conferencing tool, Teams, Zoom, maybe a line of business application or two. And the fact is, if that's all they're doing, then realistically, we're not going to get in their way. It's when they start downloading, TeamViewer or some random coupon clipper from China, then absolutely we're going to step in and block that. But that's what most organizations will want. But obviously there's differences between your average user and say a developer or an IT admin or something like that. So it's about learning something else has just got blocked, Dropbox. It's about learning what is required on each individual's machines, a human being making decisions about, hang on a second, well, any desk shouldn't be allowed in this environment, so let's block that. Okay, TeamViewer shouldn't be allowed in this environment, let's block that. I mean, the one thing that organizations will get if they deploy this is complete visibility over what's running on their machines. And that is basically step one in controlling what's on your machines, is knowing what's there. And basically in every single instance that I've worked with a customer deploying this, there is always a surprise there. There would always something on their machines that they had no idea was there, and immediately go get that off or turn that off right now. So it could be a remote access tool, it could be a WinRAR or 7-zip, or it could be 15 random coupon clipping extensions, whatever the case may be. There's always surprises, but visibility is his first step in control.
Because that warning that just popped up was literally the perfect example while you were explaining what just happened. Because I just wiped this computer, and now if you don't know, I think of Windows 10 on this one, but the Dropbox came as a pre-install. And the very first C2 that I made public it's been 3 years now. Once I came public on this name, the very first C2 I dropped was a Dropbox C2, which comes standard with the system now. And they still determined, hey, we didn't agree that you should have that. And that was standard. That was just installed. That was a fresh install right there, and it came with it. So for someone like me, I already have a Dropbox C2 that's ready. I just got to get one single file in there and it's over. And you guys just blocked it live while talking about it. That was kind of cool. So I didn't mean to jump in on you, but that was cool.
No, I mean, you must, dude. It's great because I think we really need this. It's something we discussed in our last interview. There's this huge problem where the big companies, big corporates aren't engaging with the ethical hacking community. So it's fantastic to see, this discussion, because it's really important that companies engage with the good guys like you, who are trying to try this stuff, but not try and sell it on the dark web.
Look, we've got so much to learn. And that's part of the reason why we're here.
Yeah, there's a big difference between the companies that are trying to do right and protect you and the ones that are just trying to check boxes so they're not liable if something happens. That makes a huge difference, because a lot of the exploits that I find, for example, the reason Microsoft didn't pay me out is because it didn't fit within the parameters of what they would call bounties, or there was no box to check if they implemented what I told them to. So they just decided it wasn't worth it. But like you just saw with like the descriptions in the PowerShell modules being able to store malware in there, that's still just free.
I wanted to ask about phishing because it's a huge problem. So if I'm a non-technical user and I get some phishing email, what's going to happen?
Fundamentally, you're going to be able to click on the link. Now, one of our recently added components is what we call Cloud Detect. Cloud Detect is, again, we've got a protection platform, which is everything we've mentioned so far. We've got detection, which is looking for anomalous behavior and responding to it, much like a traditional EDR. We've also added cloud detection to that detection product, which basically lets you pull in logs from Office 365 to, again, look for anomalous behavior. So the reality is it would probably be detected in that Cloud Detect product, fundamentally, we can't stop users from clicking on links they shouldn't click on. I mean, we're not an email security product per se. We will block things like, as I mentioned earlier on, the likes of Excel calling PowerShell, or Outlook calling PowerShell. We will control all of those interactions, but actual phishing links themselves, we can't really follow or stop a user from following it. And I mean, we do mitigate user stupidity to some extent, but there's only so much you can do.
But I mean, if the user tried to download something off that link, or if they tried to install malware, that would be blocked,
absolutely.
right?
No, 100%, that would be blocked straight away. I'm just talking about credential theft more than anything else. Yeah. No, if they try to download anything and get blocked, if they try and use, say, run a PowerShell script or anything like that, obviously it's going to be, controlled just the same as you saw with Jakoby's tests.
Yeah, but you could restrict which websites people go to, right? So you could stop them going to like certain parts of the world. And I hate to use examples, but like certain, like say I'm a US company and all the customers I deal with are in the US, then you could just restrict them to the US. Is that correct?
That is a feature that is coming soon. I don't want to get too specific on it. So geolocation or geoblocking is a feature that's coming soon. Right now, I mean, obviously you can block particular locations, websites, so if you want to block Mega or Dropbox is another great example, because file sharing utilities is a really good way of exfiltrating data. And again, legitimate file sharing utilities, all the better, because your AV or EDR is probably not going to kick off about it. So you can very easily set up policies to block access to Dropbox.com or Mega.nz or whatever other tools that you want.
Two more things real quick. One, when you're talking about all those different softwares for exfiltrating stuff, Dropbox, etc., I've literally authored all of those. I have made PowerShell scripts to use every single one of them. Mm-hmm. One of the pages on my site literally goes through all of them one at a time.
If it uses PowerShell, though, it will probably block all of them. Again, not because of specific network denies, just because PowerShell can't get out in the internet.
And also, I just did want to point out that, David, you had brought up about blocking websites from other countries. We do also have the software health report, where it isn't websites, but it'll tell you what applications are running in your environment and where they're based out of. So you can just see, maybe I don't want software running from a certain country. You can just go in that and then find what's running from each country you don't want it running from, and then just remove that software.
So Nico, you picking it up on the management console thing, right?
Yes, we have ununified audit, and we can see all the traffic that's going in there. Another funny thing as well is that while we're also putting in source control, putting network control, I also put in some detect policies, because since I knew you're using PowerShell, in the worst case scenario, if any of our applications ring-fence weren't able to run, one thing I knew, no matter how you tried to hide everything, since it's PowerShell, you'd have to run it using invoke expression. So I made a little policy that checked for use of IEX or invoke expression. So we have a alert for every single time that you've ran every single time that you've ran your stager on the computer.
I want to ask you this, because this is just like in the back of my mind, is management of this. It sounds like a lot of work, or is that incorrect to say that?
So that's specifically speaking about Jakoby's environment and setting up Jakoby's environment. So as I said, we did sort of sprinkle a little extra security dust on that particular setup. But for most organizations, we have a set of what would be best described as one size fits most policies that most environments can basically run with comfortably, with one or two additions, maybe a line of business application or two. So in most cases, it is just a case of pushing the agent out, learning what's there, having the policies created automatically. So there's no heavy lift. One of the other things, for anybody who has ever had any experience with allow listing solutions in general, they'll know that probably the biggest problem with allow listing, aside from building those initial policies, is the problem of what happens when software updates. And generally speaking, what happens when software updates with most tools is it breaks, because a hash changes, your allow listing tool goes, look, I know that file is called acrobat.exe, but it doesn't match my hash, so I'm going to block it from running. And then you have to respond, you have to get things added, etc. So one of the sort of secret sauce parts of ThreatLocker is we have this concept of what are called built-in applications, which is a database of over 4,000 common applications that we track and monitor and update when they update. So if Acrobat updates, we're going to basically capture those files, those hashes, add them to what are called our built-in definitions. They get pushed down to any customer who's using them automatically. So what that means is those customers don't need to worry about updates to software causing problems. We're effectively taking that responsibility on for them. So between those two things, the automated learning at the beginning and also the built-in applications, in most cases, it is just a case of push it out, jump on a call with us a week later. We'll show you everything that's been learned. Do you want to turn this off? No. Do you want to turn that off? No. Repeat that maybe once or twice, maybe 3 times at most. And it's just an hour a call. Repeat that a couple of times, at the end of which you'll be in a position where you can turn it on, safe and secure in the knowledge that it ain't going to break things. So it's not a heavy lift. And I just say, David, I have spoken to customers who have implemented similar solutions, and I know what a pain it can be. I mean, I spoke to one organization who have spent, and this is not an exaggeration, 4 years on a project. 4 years on a project trying to implement a low listing, and they still haven't turned it on. Well, sorry, I tell a lie. They turned it on once and it blue screened a bunch of machines and they turned it off really quickly. But that's the kind of undertaking it used to be, whereas we've got solutions engineers who are working with, customers of tens of thousands of machines that they get secured in, 6, 7, 8 calls.
Another question I think a lot of people have is support. It's great to have a product, but what happens when things go wrong or I'm not sure what to do? What kind of support do you guys have?
24/7, 365. And I know I'm biased, but the best in the business by a distance. I've been on the other side. I've been the IT guy dealing with a vendor, and I know the pain of not getting good support and, logging a ticket and somebody gets back to you days later going, hey, is this a problem? Obviously, the nature of what we do, speed is important. If somebody has a problem with something, they need to get that problem fixed quickly. So we have, as I said, 24/7, 365 human beings answering calls or answering chats, not AI, not bots. And I think the average is somewhere between 20 and 30 seconds currently. So you will talk to a human being, who will be able to help you and quickly. So yeah, support is the best in the business as far as I'm concerned. And same applies to the solutions engineers, so the guys who actually help with the onboarding. So they're literally the tech resource that, helps a customer through every step of the process, from configuring all the different modules, what they should do, what they shouldn't do, best practices, what they should look out for, all that kind of stuff. It's all free. It's all included in license costs. There's no implementation costs. There's no extra charge for any of that. It's all, as I said, included. And again, best in the business by a distance.
Jakoby, I've got to give you the last word, man. What are your thoughts?
I think it's really cool that someone is trying to do something outside of just checking the boxes, like coming down to it at the end of the day. They're creating new boxes and finding new boxes that need to be checked, and not just trying to maintain safety against liabilities. I just think that's probably one of the biggest strengths that they have, being able to step outside, look outside the box, and acknowledge other variables that other people aren't even looking at.
And I must say, from my side, the reason that we did this video is because of that interview where you mentioned them and recommended them as being like the only company that was able to block your stuff. And I'm pretty confident, if they can block you, then the world's going to be a much safer place. So thanks to everyone who joined this call, and thanks to everyone who's watching. Please put your comments below. I'm hoping that we will see more with Jakoby and ThreatLocker, and you can come back for another demo, and hopefully they'll beat you, Jakoby. But I mean, as you said, bittersweet.